All right. You can literally be able to draw this out, no problem, at any moment. And I'm going to show you how, and I'm serious, it's that easy. So I'm near, I have 2 weeks left, okay? I'm actually on campus right now, if it's not obvious. I have 2 weeks left, and I'm nearing the end of my calculus, like all of it. Unless you count differential equations and linear algebra as calculus courses, I mean, they technically are, but they have different names. So what I'm trying to say here is, I actually always struggled with my unit circle up until this point. And the fact that I made it this far is crazy. But a buddy of mine showed me this semester, like 2 weeks ago, this method, and I just want to document it for, the sake of seeing it again, and also in case anyone else ever comes across it, and I think it's extremely helpful. So there is this is the device that we went over on how to memorize the unit circle, okay? So you always start with this plane, okay? Just like a graph. So we have an X and a Y plane, okay? Now there's a circle on that plane. It might look something like this, who knows? That doesn't look very good though, does it? You know what, we're just gonna roll with it. So this is supposed to be imagine this is a perfect circle. Okay, so in this, we're gonna split up. We can see that we have like 4 different sections. We're just gonna split them up into halves. Oh my goodness gracious. So this is 1/2 of that, a half of this, a half of this, and a half of this. Okay, so let's think of these as like the slicer that we used for these 4, 1, 2, 3, 4, are, let's imagine that these are big slices, big lines, so these are bigger lines, and then what we're gonna do is we're just gonna do another half of each of these. And let's imagine that these slices, and what I'm trying to say is the lines that we're using to go through here, like let's just imagine these are a little bit smaller, okay? So, there we go. Now, here's where things start getting pretty epic. It's really not too crazy. So we're gonna start counting, we're just gonna number these lines, okay? We're gonna number them. And what we're gonna do is, as we're numbering them, we're just gonna skip over these 4 bigger ones, okay? That we did in the as our initial slices. So this is 1, we're just gonna skip that. 2, 3, 4, skip. 5, 6, 7, skip. 8, 9, 10, skip. 11, 12. Okay, that's literally what we do. And the thing is that you have to remember is that all of them are just going to be over 6. Okay? Over 6, over 6, over 6. Right? All the way through. Not too tricky. Okay? So, with that in mind, just everything's multiplied by pi, okay? Because it's a circle. And circles, and pies are in the shape of circles. Okay. Okay, we have almost all our radians done. Now, what do we got to do about these big guys? Why did we skip over those? Well, that's just because those values are going to be a little bit different. We have to account for them differently. So just remember it this way. We're pretty simple up to this point. Okay, number everything one, just counting up from 1 all the way around, going counterclockwise, and we're just skipping over the big ones. And then divide everything through by 6. That's it. Now, these we're also going to number, but we're just going to number the 4 of these, just going up by 2 in each one. So 1, and then what's 1 plus 2? 3, and then what's 3 plus 2? 5, 7. So 1, 3, 5, 7, okay? And then these aren't going to be over 6 because they're the exception. So these are just going to be over 4. You can remember that because we have the 4 big ones are different than all the other little ones. 3 over 4, 5 over 4, 7 over 4. And then of course, just like everything else, just multiply these by pi as well. What's going on? Okay, here. Bada bing, bada boom. Okay, so we have all our radians. That's pretty much, that's it. Now what we just have to do is find at each radian what the x and y values are. So the way to do that is we're just going to number more stuff. So we're going to be counting. I think of doing this a little more like counting. So what we're going to start with here is let's just do all the x values. So we know it's going to be organized like this, right? Where we count for cosine as related to x, and then sine as related to y. So cosine x-axis, sine y-axis. All right, I'm cool with that. So what we're going to do here is let's just worry about the x value. We know that at each of these radians, there's some set of values, just like a point would be set for like a graph, and we have to know how to find them. Well, I'll show you. It's really quite simple. Okay? So what we're going to do is let's just worry about the x part of that set right now. So 3, 2, 1, 0. Okay? Well, we're at 0. Let's just count. We're going to count back up again. We're going to reset. 1, 0. So 3, 2, 1, 0. 1, 2, 3. Okay? Here is the little thing that seems odd, but that you have to remember is that this is going to be -1. Okay? And we'll see why in a second, but it's because the way to remember that is that on the x-axis, right? So if we have x, y, these are all the negative values on the x-axis going this way. Positive values of x, the way this is split, positive values of x here, negative values of x going over here. So -1. Okay, so we just reset. So let's go and start counting down again like we just did from over there. So 3, 2, 1, 0, 1, 2, do that here, 3. And then +1, because positive values for x here, and the negative for x on this part of the axis. Now, what's happening here is, if you haven't noticed, I'm trying to iterate that it's just like a graph. So what we're thinking about is right now we're just thinking about the x part of these points that we're finding. Well, when you think about it, the y-axis, of course x is going to equal 0 on the y-axis, because for every value that could possibly be on the y-axis, there's no value for x, because on a two-dimensional graph, what happens is whenever you have a value for x, it's bringing it about at some value horizontally. Well, we're just laying flat on the y, no values for x are going to be accounted for in any of those points, because they're all going to be 0, since we're not moving along the horizontal at all. We're just staying along the y-axis. So that's why here we know that cosine, aka the x value of the point, is going to be 0. And then here it's also going to be 0. So that's a way to remember how to count for this too, where we're going, okay, let's just worry about the x. 3, 2, 1, 0. Start counting up. 1, 2, 3. -1. But then 3, 2, 1, 0, 1, 2, 3. Okay? So that's the mnemonic device to use. The iffy little like hill you have to just remember to like get over a little bit when you're drawing this out is that 1, -1. But other than that, 3, 2, 1, 0, 1, 2, 3, 3, 2, 1, 0, 1, 2, 3. Okay? Now, here's the awesome part. For the y values, it's also that easy, except now it's even easier because what we're going to do is just whatever value that we had here for the x, when we're counting like up this way, we're going to just do the opposite. So 3, 2, 1, 0. Okay, for the y's, we're going to do 1, 2, 3. Okay, x's are 1, 2, 3 here. Well, 3, 2, 1. Okay, 3, 2, 1 here. 1, 2, 3. And then this is probably confusing, so let's start making these in actual points here. Like this. Okay. Oh, I can stay somewhat organized. Numbers are flying around. Okay. Right? 0. Okay, so 1, 2, 3. 3 for the y, 2 for the y, and then 1. Now, you're like, why am I drawing big parentheses? That's because there's just one more like little trick to remember when going around it like this. So you can see, I want to skip over these. I don't want to make it too confusing because it is that easy to remember doing each of these. Like these little sub slices here in the quadrants are that easy. It's just the hiccup. It might be remembering, okay, these, right? Well, let's think about it the same way intuitively. On the x-axis, what are the y values going to be? They're going to be 0, aren't they? Okay. Well, what does that mean for on the y-axis? When x was 0, then y is going to be 1. Okay, because y is just going to be 1 here if x is 0, and then in that same sense, it's going to be the same thing going down here on the negative part of the y-axis. But this is the negative part of the y-axis, right? Just like a normal graph. The positive values up on here, and you start going, okay, positive 2, positive 1, 0, negative 1, negative 2. So negative 1 here. Now the last little trick of this is that all of these, literally all of them, are over 2, except for the except for the main, the 1, 0, negative 1, 0, 0, 1, 0, negative 1, you just leave those. But all of the sub slices here, the 3, 3, 3, 3 in the quadrants are all going to be over 2. This. All over 2. Okay. Oh, see, not these ones, but yep, all of these over 2. Okay? Now, they're all over 2, and all of their numerators are going to be square rooted. Square rooted, like this. And that literally means all of them. Again, all these ones, these are just as easy as 1, 0, negative 1, 0, 0, 1, 0, negative 1. But all of these, yep, square root, all their numerators. That even accounts for the 1/2, but that would be the square root of 1 over 2, and the square root of 1 is just equal to 1. So we just don't really account for those. They don't really matter that much. You can write it out. You can write negative 1, the square root of 1 over 2, but you just don't really write it out, like, because that's like writing 1 plus 0 in all your equations. And you're making more of a mess. And I try not to make messes. I try to clean them up. So we're literally pretty much almost just completely done with the unit circle here now, except that remember what matters about the x and y axes where the values are negative x for this part, and then negative y for this part, right? And this is positive x, and this is positive y. So let's think about it like this. This is the first quadrant. Well, all the values in the first part of this quadrant are positive, because positive x-axis, positive y-axis. Awesome. This is quadrant 2. All the values okay, this is quadrant 1. This is quadrant 2. All the values for y are positive now, but all the values for x are negative, because that's the negative x-axis. So we just account for these in the points. So our x part of the point, right, is going to be negative. Like this. Okay. Cool. This is the third quadrant. And in the third quadrant, let's look. I literally think about it intuitively every time I draw this out. And I go, okay, let's look. Negative values for y and then negative values for x in this quadrant. So these are all negative values, because negative x, negative y. So negative x, negative y, negative x, negative y, negative x, negative y. Okay? That leaves one more quadrant, which, yes, is the fourth quadrant. And let's look. Positive x values, negative y values. So positive x, negative y, positive x, negative y, positive x, negative y. And there you have it. That is the unit circle. So find, when sine is equal to the square root of 3 over 2. Okay? So you're looking at these points. Well, square root of 3 over 2, and for the y value of the point, that's 4 pi over 6. And then just simplify that. So 4 pi over 6 simplified is 2 pi over 3. So we know we can find all this stuff now. What if you want to find when sine is equal to this negative square root of 3 over 2? Well, negative square root of 3 over 2, and for the y value here, that's going to be sine. So sine is equal to the negative square root of 3 over 2 at 8 pi over 6 radian. And that simplified is divided by 2, 4 pi over 3. So that's the little device. That's how you can draw out the unit circle every time. And I think it's extremely helpful to think of it this way. And before then, I never really had a good way to draw it out. But yeah, that's it.